Okay, students, so we have made these parts, 9 parts, and we are going to do the assembly of these parts. Okay, so we will come to the SolidWorks. We'll open SolidWorks. Okay, so go to the assembly. Now, our part 1 is the frame. As you can see from here, this is part 1, which is the frame. So we want frame to rotate about this bracket. So we do not want frame to be fixed. Rather, we want bracket to be fixed. So this belt tightener uh, is actually an assembly in which this frame rotates about the bracket. And when the bracket is going to rotate, all the pins and everything are going to rotate with the bracket. This pulley is going to rotate as well. So we are going to bring this bracket first. So bracket is going to be the first part which we will bring in our assembly drawing because we want to make it fixed. So bracket is actually our part number 3. So we are going to bring part number 3 first of all. Okay. And okay. So there it is. SolidWorks. So go to the assembly now, browse. You can go to assembly, insert component, browse, and we will go to the desktop. We will go to the desktop and we will come here. Desktop. Okay. And belt tightener. And then over here we have this part number 3. We will bring this part first. Okay, so the units doesn't matter anyways. You can change it to millimeters or in inches. When you are sketching something in assembly, then the unit matters, or you are dimensioning something, then unit matters. So this was actually the first part. Now we are going to bring the rest parts in. So insert component and click on this part first. 1, 2, 4, 5, 6, 7, 8, and 9. Click open and bring all the parts one by one. This is first, this is second, this is third, this is fourth, this is fifth, this is sixth, seventh, 8. Okay, all 8 parts are brought in. Now you can, we need 2 more, what is it called? 2 more pins, because we need 2 pins and we need 2 washers. So we are going to bring part number 6, which is the pin, and part number 4, which is the washer again. So we are going to go here and we'll bring part 6 and part 4 again. So part 4 and part 6 again. Okay, this is part 4 and this is part 6. The orientation is not correct anyway, doesn't matter, we will flip it when we'll do the assembly. Now how it is joined, we have to see how these things are joined together. Now, first thing is that we are going to fix this wheel with this pulley with this frame. Okay, you can start from anywhere you want. It depends on you now. Okay, so you can see from here that this bushing is going to go inside the pulley. Okay, first we are going to place the bushing inside the pulley. And what is the length of the bushing? The length of the bushing is 63, as you can see, and this length, the inside, the whole of the inside hole of the pulley has got a length of 63 as well. Okay, and what's the outside diameter of the pulley? If you can see, it is how much? 26.9, and the inside diameter of the hole is again, as you can see, it is 26.9. Okay, it's written there. So this is good. This is the first thing which I'm going to do because it's easy and I can join these two, assemble these two parts together. So over here we have got this pin. Okay, we can change the color of the pin as well if we want. You can change the color. Okay, so that they look different. You can come here and choose any other color you want. Okay, make it red. So there is the pin. Now what we'll do, we'll bring this pulley over here and we will click on made and we will click on this circle. Do not select the face. No, we do not want to select the face. Click on this circle and this circle over here and make it concentric. Okay, so this is concentric. Do not lock the rotation. Okay, because the pulley is going to rotate with respect to the bushing. If it is if there is a clearance fit between the pulley and the bushing, then you can lock the rotation. But if it's an if it's a clearance fit between the pulley and the bushing, then you cannot lock it. If there is an interference between the pulley and the bushing, then you can lock it. But normally there is a clearance fit between the pulley and the bushing, and you can see, no, over here you can see this is the oil channel. So over here you will have the interference fit. Over here normally we do have the interference fit, and between the shaft and the bushing we have the clearance fit. So we can lock the rotation. We can lock the rotation because we know that there is an interference fit between the pulley and the bushing, because there is no oil channel over here in the outside, but there is oil channel inside. So when you have oil channel, then this means that the two mating parts have got the clearance fit, not the interference fit. So I have locked rotation, so it's not going to rotate. Click OK, but this can come out. This part can come out, as you can see. So what I have to do, I have to apply another mate. I have to click on this surface and this surface, and I know that they both have the same, you can say, the depth. Okay, or you can say the depth of the bushing and the depth of the inside hole of the pulley, they are same. So you can choose the two surface. You can choose these two surfaces and make them coincident. Okay, so now this is done. Now what is the next thing? You have to place this pin inside this bushing, and how it is placed. Let's see what is the outside diameter. The outside diameter of this pin is, as you can see, how much is the outside diameter? It's 19. As you can see, it's 19. So the outside diameter is 19, and over here from this side it is 22. Okay, this is 19, this one is 22. And what is the inside diameter of this bushing? It is 19. So we can see that this bushing is actually, this side, which is 19, is going to go inside this hole. Okay, this 22 diameter cannot go inside the pin. Okay, so we can see this thing, but we are not going to do it right now because the pin is going to come first. We are going to place this inside and then we will place the pin inside. First, we will place this bushing and the pulley inside this frame, and then we are going to do that. This is the next step. But before doing that, we have to place the washers. What is the thickness of the washer? You can see it's 3 millimeter from here, 3 millimeter from there. So 3 plus 3 is 6, and the inside length is 63. So 63 plus 6 is 69. And you can see that 70 is actually the distance between the two faces, one face over here and one face over there. So distance between the two faces actually 70. So there is actually a 1 millimeter clearance between the two faces. Okay, so let's what we can say, place the pulley inside first of all, inside the frame. Okay, let's place the pulley inside the frame. First make the washers coincident. Okay, so click on the two washers. So you have this washer. First select this one, this edge, and select this circular edge and make it concentric. And you can unlock the rotation, because over here the washer is going to rotate. It's not, fixed with the pulley. The washer is allowed to rotate. You can unlock the rotation. This is okay. So you have another washer, but this washer can move, this can move. So what you can do next is that click on this surface. Strictly speaking, I should apply a distance made between this surface and the surface of the washer. Strictly speaking, I should apply distance made, but that distance made is going to become very complicated. Okay, because this washer is actually allowed to move like 0.5 millimeter this direction, and the other washer is also allowed to move 0.5 because there is a 1 millimeter clearance. So, but we are not going to go into that detail. Just click on this surface and this surface and make it coincident. That is also acceptable. Okay, similarly we can click on this surface and this surface over here, okay, and make it coincident. That's fine. This is the first relation. And then, okay, done. We have this edge and this edge, not sorry, surface is selected. Delete this surface because the surface is selected. I'm going to select this edge. The edge over here, you can select any edge. Okay, this edge and this one. Why it's not selecting? Is it already selected? No. Okay, so we are going to select this edge and this edge, not this surface. Okay. Sometimes, if the circle is, sometimes it happens that this doesn't, when you have the surface, when the circle is actually on, you can say, because this is, it's slopey. So when you have a slopey surface connecting with the circle, it sometimes, make trouble. And in this situation, what you can do is that you can select the inside surface of this one and the inside surface of this one and make it concentric. But it's not happening. Anyways, we'll see what's the problem. It happened for the previous washer, but it's not happening over here. What we can do, we can break the previous made. Let's break the previous made. First of all, delete this made. Let's make the concentric made first. Okay, so we have to make the concentric made first of all. So go to made. This one is there. Where is it gone? Not point anyway. Where is the polygon? Washer. Washer is there, Now this is the problem. When something is not fixed, it moves all around, Okay, so go to made again. Click on the edge over here and click on this one. No. I'm trying to select this one, but it's not. Anyway, what I can do next, what other option do I have? I can go to this axis, view axis, and now I'm going to try to select these axes. So this axis is selected, okay, and there is an axis over here which I'm going to select. Now make it coincident. That's the option. I don't know why it happened for this one, but it's not happening for the other one. I don't know what's the problem. Anyway, now it's actually coincident because I have made the two axes coincident. This means the two circles are concentric. Okay, now what I will do, click on this one, this side, and click on this side and make it coincident. Now this is coincident, and this is actually your, now four parts are assembled together. Now we are going to bring all the four parts, okay, over here. Okay, we can place all these four parts over here. Okay, move it over here and click on this mate, click on this circle and the circle over here, which face is selected. Yeah, there it is. This has circular edge is selected, and make it concentric and do not lock rotation. Okay, now this can move inside. This is concentric and it can move inside and outside. Now we have to apply, we know that the distance from this surface on the frame to the other surface is 70, but the distance from one outside of the one washer to the outside of the other washer is 69. So there is actually a 1 millimeter gap. As you can see, the gap is already there. You can see the gap. There is a gap on both sides, and this is actually the sum of these two gaps is actually 1 millimeter. Okay, and this pulley is allowed to move within this gap. So what I'm going to do, I will apply a distance mate. You can go to the mate and you are going to go to the advanced, and there is an option for this distance mate. Okay, distance. Okay, remember this is nothing. This is nothing. These two numbers are important. This tells you the present position. Okay, this number is nothing. Now I want that the distance, minimum distance between this surface and this surface. I am going to first of all select the two surfaces. With respect to which two surfaces I want this distance made to be. So the first surface is this one and the second surface is this one. So I want the distance made between these two surfaces. Now when I say 1 millimeter, this means it's 1. When I say 11 millimeter, it becomes 11. This tells you the present position. Sorry, this one, this number tells you the present position. Okay, it has nothing to do with the mate. You are not going to define any angle between the two surfaces. Now I want that the minimum distance should be 0. Okay, the minimum should be 0. What is 0? 0 means the two surfaces are coincident. Okay, and what is the maximum? Sorry, maximum is 0. Sorry, maximum is 0. This is the maximum. This symbol is for maximum. Maximum is 0. Sorry, maximum is 1 and minimum is 0. So you can enter 0 here. Okay, maximum is 1 and minimum is 0, and click OK. And when you click OK, you can see that if you bring it in the front view, that's not actually the exact front view. The front view is, remember, with respect to this thing. Okay, when I click on front view, this is going to be front with respect to this is already rotated. So that's not going to be in exact proper position, but you can see that you can move it within 1 millimeter distance. Either it's because I have applied mate over here. So either it's going to be minimum is going to be 0, maximum is going to be 1. So this pulley cannot, go outside this. Okay. Now what is the next thing? I have to put this whole thing, this pin inside this. Okay. For easiness, what you can do, if you think that this part is rotating and you are unable to do it easily, what you can do is that go to frame 1. Frame 1, where is frame 1? This is part 1. Part 1 is actually frame 1. Left click on it and click fix. When you click fix, you can see that it becomes F. Now, for the time being, we are going to make it fix. But after that, when we have inserted all the parts, we can unfix it. Okay. Because this frame is actually going to rotate about the bracket. So for the time being, so that it doesn't, rotate. Now, when it's fixed, it's not going to rotate. So you can place your pin easily inside the frame. Okay. Now, see over here how the pin is placed actually. So you can see that this diameter is 22 and this diameter is 22 as well. So the 22 portion is going to go inside this 22. And what is this length? This is 25. This is 25 and this is also 25. So this means that this portion is going to go completely inside this. Then you have a diameter of how much? 19, as you can see. This is 19. And this 19 is going to go inside this 19 millimeter bushing. Okay. And what is the length of this thing? It's actually 70, as you can see. But this one is 63. So 63 plus, this is also 19 and this is also 19. 63 plus 3 plus 3 is 69. So this is 70. So this means that this is going to start, this part of the shaft is going to start from this side and it's going to end on this side. Okay. And then this part will go inside this one, which is actually the diameter, as you can see, is 16. And this diameter is also how much? 16. You can see M16 written there. Okay. So what I will do, you can change the color of the pin if you do not like. Okay. Because I want to make it colorful. So let's change this color and make it like green. Okay. Make it green. And I know that this diameter is 22, this diameter of the hole is 22, this length is 25, and this is also 25. So I'm going to first of all make it concentric. Insert mate, click on this circle, on this one, make it concentric. Okay, this is the first thing. And then what's the next thing? Click on this surface and this surface and make it coincident. Okay, because we know that these 22 diameter hole and shaft, they have got the length of 25 millimeter. So this 25 is going to come here. Okay, as you can rotate this. Okay, now this is coming on the other side. Now you have to place a nut over here. Where's the nut? This is the nut. Okay. Okay, one thing I forgot. One thing I forgot about the Woodruff key actually. Okay. I forgot about the Woodruff key. And one more thing you should notice is that this shaft can rotate, This shaft can rotate, okay, as you can see, because I haven't locked the rotation. So I have to place the Woodruff key inside, which I forgot actually. Okay, let's see where the Woodruff key is going to come. So I should have done it before, but okay, where the Woodruff key is going to come. The Woodruff key, one part of the Woodruff key is here and the other part is actually there. Okay, so here is the Woodruff key. So when I was inserting the shaft, I should have placed the Woodruff key inside. Okay, what we are going to do, we are going to suppress this last two mates. Suppressing mates mean these mates are right now inactive. Okay. When you suppress these two mates, these are now inactive. You can, bring the shaft out. Okay. But the advantage of suppressing over deleting is that when you suppress, you can unsuppress as well. But when you delete, it's permanently deleted. Now you cannot undo the delete. So it's better to suppress when you see these types of issues. So what do you think? Where is this Woodruff key going to come? So this Woodruff key is going to come over here actually. I can rotate this. Where is the option for rotation? Move component, rotate it actually. Okay, rotate this thing so that you can see this portion at the top. Now what I will do, I will bring this Woodruff key over here, change the color, because the Woodruff key, we have to do two types of mates for the Woodruff key, and we want it to be visible while we are making the mate. Change its color to like purple or something, something like purple. Okay, so that we can easily identify the Woodruff key. So there is the Woodruff key. Now this is the axis of the Woodruff key. Okay, so the two axes are, or you can select the two circles. You can go to the mate, select this circle, and select this circle, this circular surface which is inside. Okay, this one, not the face actually. No, this circular edge. There it is. And make these two circular edge concentric, not coincident. Concentric. Okay, so when you make it concentric, this means the two circular surfaces are concentric. Okay, there it is. So these two circular surfaces are, the two circular edges are concentric. Now what we are going to do, we will make the two faces coincident. This one, which is over here, and the face over here, and we are going to make it coincident. Okay, now you can see, you can rotate the Woodruff. Now when I'm trying to rotate it, it's not rotating. What you can do is that fix this one as well for the time being. So which part is this? Let's check it from here. This is actually part number 5. Fix this one for the time being. Okay, fix it. And you fix it, this is now fixed. Now it's not. Now you can rotate this. So you can see that it is actually, concentric, and this surface is coincident, as you can see. But this surface, this surface should be parallel to this top surface, or we can say that this edge, the edge over here, the edge of the Woodruff key, this one. Yes, is the edge selected? Yes, it's selected. I don't know which edge is selected, but I'm going to select this edge, this one. This edge is parallel to, is going to be parallel to the axis. So when you make the two edges parallel, this Woodruff key is now going to be, straight. So I have selected this axis. So turn on these axes. Remember, turn on both axes. These are very helpful when you are doing the assembly. So this axis, this edge and this axis, they are actually parallel, and click OK. And when you click OK, now you can see that the key is not going to rotate. Now this part is done. Now we have to actually make sure that this surface, which is actually over here, and the surface which is inside, okay, the surface which is inside, which is actually over here, this surface. Okay, these two surfaces have to be parallel, not coincident, remember, because there is some gap between the two surfaces. Okay, so they are actually parallel. So the parallel mate is actually very important in some situations. You will find it out that it is very important, but you will have to unfix this one. We fix this, that's why it's not rotating, So click on this and make it float. Okay, now you can, rotate it, move it, rotate it. Okay, and now make this one, this concentric mate, unsuppress this. Now what's going to be the advantage of unsuppressing this? When you unsuppress it, you can actually, it's going to come in line. Now, what I have to do, okay, I haven't unsuppressed this one, because if I unsuppress it, then I will not be able to make mate between this key and this surface. So first I'm going to make the mate and then I will unsuppress this last one. So what I will do now, go to the mate, okay, click on the top surface, this one, and click on the surface over here, which is this one. Oh, which face is selected, I don't know. Now you have to be very careful, okay, this one. Okay, so the two surfaces are selected. So this surface is actually phase 3 of part 1, and this surface is actually which is this. Okay, if you do not know what is this one, then you can reselect it. Okay, this is phase 2, so I selected a wrong surface actually. Now you can see that it rotated and it aligned actually, and make it parallel. Do not make it coincident. It's not, this mate is not going to occur. If I try to make this mate and click OK, it's going to give me error. It is going to say that add this make or break other mates, because we have made a concentric mate. It's not going to happen. So we have to make it parallel. Now this parallel mate is going to occur. Okay, so let's do it again. It went away. So click on this surface, this one, phase 2, and click on this surface, which is over here, which is actually phase 3, and make it parallel. And when you made it parallel, click OK. Now this is not going to rotate. Even if you try to rotate it, this is not going to rotate. Okay, because there is a mate between this surface and that. So it's not going to go away. Now what you can do, you can unsuppress this one. Unsuppress. When you are going to unsuppress, this is going to go inside, and the Woodruff key is actually inside. Okay, if you make the section view, now when I make the section view, it's actually the orientation is wrong actually. This orientation of the plane is actually with respect to the bracket. Okay, I can change the angle as well if I want, but okay, I can change it, but I will have to do some work. Okay, now you can move it inside, and when you go inside, you will see that there is actually a Woodruff key. Okay, so where is the Woodruff key? There it is, this one. Okay, this is the Woodruff key. So you can see that the Woodruff key is there. There it is. Okay, so if I click OK, you will see the Woodruff key. Okay, so Woodruff key is actually at its proper place. Okay, so this was actually the slot which we made. Remember this slot, this is actually the cutaway model, but you have actually a slot over here. And because of this slot, if I turn this off, you can see there is a slot, and because of this shaft is not going to rotate. Okay, now we have done most of the work. Now only the nut is remaining. Now this side of the nut is going to come outside, and that nut is going to go inside. A very important thing, first of all, we are going to make a concentric mate. Okay, click on the mate, unselect this, click on this axis, which is over here, and click on this axis, which is over here, and make it coincident. Click OK. Okay, now we are going to make what type of mate we want for this nut. We want a screw mate. So go to advanced, go to not advanced, mechanical, go to mechanical and click on this screw. Now over here it's given revolutions per minute. Revolutions per minute means revolutions per millimeter, not minute, sorry. Revolutions per millimeter means how many revolutions it's going to make when it moves a distance of 1 millimeter while rotating in the screw. Okay, so remember, revolutions per millimeter is same like teeths per millimeter. You can say teeths per millimeter. the number of revolutions per millimeter is going to be the number of threads, not the teeth, threads per millimeter. Okay, so it is same like TPI. If TPI is given to you, then you can choose this, or TPM. In this situation is going to be TPMM. Actually, it's not inch, it's in millimeter. So if teeth per millimeter is given to you, or you can say the threads per millimeter, then you are going to choose the top option. But this distance per revolution is actually the pitch. Pitch is actually how much distance is going to cover when it is rotated one revolution, and it is going to cover the distance equal to its pitch. If the lead is 1, this is what we discussed in the theory as well. Now in this situation, sorry, if there is a not lead, if there is a like a single thread, if there is a single thread, then the distance per revolution is going to be equal to the pitch. Okay, and in this situation lead is going to be equal to pitch. If there are two threads, then the distance per revolution is going to be more, it's going to be double than the pitch. Okay, so this is what we discussed in theory, but in our situation, because there is a single thread, so the distance per revolution is going to be equal to the pitch. What is the value of pitch? You can see from here. Okay, so the value of pitch is actually 2. Here it's written M16 into 2, so 2 is actually the pitch, and on the nut side you can see it's the same, M16 into 2. So we are going to enter 2 over here. So we will enter 2, and you have to be careful about the reverse. We will have to check it actually. Okay, because sometimes this one you will have, sometimes you have to check the reverse, sometimes you have to uncheck the reverse. It depends on the direction actually. Okay, so this is actually 2 millimeters, and select the surface in mate selection. So in case in mate selection, you have to select the faces, Okay, so click here and select this surface, the inside surface. Okay, so I'm going to select this inside. Okay, why it's not selecting? It selected, but I want to select this face, this one. Okay, so this is actually the screw mate. Let's select this portion actually first, then this one. Let's do it again. Okay, I don't know what happened. Go to mate, click on mechanical, click on screw. This is going to be 2 as we discussed, and in this one we are going to select this face. Selected entity is not valid for the current mate type. Okay, why it is not valid? Okay, let's select the axis, this axis. Okay, and let's select this axis, the axis of this one. So 2 axes are selected, and let's click OK. Okay, so it turned out to, it again turned 1. So you have to make it 2. You have to make sure that this is 2. Now we have to see whether this is okay or not. Let's uncheck it and see. Okay, so the 2 axes are selected, and click OK. Okay, now try to rotate. Now when I'm rotating it, how it is going? Look, it is traveling. When you are rotating one revolution, it's going 2 millimeter inside. But we know that this thread is what? It's a right hand thread. And the property of the right hand thread is that when you rotate clockwise, it goes inside, isn't it? When you rotate clockwise, it goes inside. But in this situation, when you are rotating anti-clockwise, it's going inside. This is not correct. So what we will do, we will reverse it, because we want that when we rotate clockwise, it goes inside. Look, right now I'm rotating anti-clockwise and it's going inside. Okay, anti-clockwise from where I'm doing. So I want that when I rotate clockwise, it goes inside. So I'm going to reverse it. Okay, reverse it. Now look what's going to happen. When I rotate anti-clockwise, it's going outside. So this is, when you reversed it, now this is the correct This is the correct, I mean the thread, but the thread is actually going inside, as you can see. So what we are going to do, we have to limit it. We have to limit it. So what we can do is that in this situation, okay, we are again going to go to this advanced made, and this option distance made, and the minimum distance what we are going to describe between these two surface, this surface and the surface over here, I'm going to describe the minimum distance to be 0. Okay, 0 means these two surfaces are close to each other, and the maximum can, now it depends what maximum you want to define. For example, I define the maximum to be like this surface and this surface become same. So we have to go back to the drawing, and we can see that actually this thread length is actually, how much is the thread length? Okay, what is this total distance? This is 134, as you can see. This is 134. The total length of the pin is 134. And from this side to this side is 120. This is 120 and this total is 134. So this means this is 14 millimeters out, isn't it? So from here, because we know that, okay, let's explain to you again. The length of the pin is 134 and the distance from this surface to the distance from, okay, just give me a minute. The length of the pin is 134 and the distance from this surface to this surface is 120. So the pin is actually 14 millimeter out, isn't it? It's 14 millimeter out. Now let's see what's the thickness of the washer. What is the thickness of the washer? Now if I come back here, you can see that the thickness of the washer is 9. So 14 minus 9 is 5. So if I make the maximum distance 5 millimeter, this side of the washer will be coincident with this green side. Okay, this gray side of the nut will be coincident with this one. So the maximum limit I'm going to take is 5 and the minimum I'm going to take 0. This is what I'm going to do. So now let's come back over here, go to advanced, go to limit, select the two surfaces, one surface over here. Okay, do not select the axis. Select the two surfaces, one surface over here and another surface on this side. Okay, and then I will say that the minimum distance is 0 and the maximum distance is 5. Okay, and click OK. When you click OK, what's going to happen if you try to rotate it, okay, in this direction, for example, okay, click on one point and try to rotate it. Okay, so it's not going to go inside. Look, it's not going inside. But when you try to rotate in the opposite direction, remember this is the right-handed thread. When you try to rotate in the opposite direction, no, look, it's not coming out. Okay, because we have made a distance made of how much? 5 millimeter. 5 plus 9 is 14. Okay, 9 is actually the thickness of the nut. So now 5 plus 9 is 14. Now this is okay. You can, move this nut at the end. Okay, make it at the end. Move it at the end. Now this is done. So now what is left? This is left actually. So we have got two pins and we have to place everything inside the bracket. Remember, the first part is, now these two parts were fixed. I made this part fixed as well because it was getting difficult to insert the part. So I'm going to make this part 1, which is the frame, I'm going to make it float. And remember, this bracket is always fixed. This whole thing is going to rotate with respect to the bracket. Okay, so we are not going to make this one float. And all the views which you see, front view, the side view, they are actually with respect to the first part which you inserted. Okay, so you can see that this is actually, now this is actually the right view, but this is not the proper right view for this one because this is actually rotated. Now what we'll do, we are going to go to mate again, select this circle, and this circle and make it concentric, and do not lock rotation. Okay, do not lock rotation. Now what is the next thing? Come back and see what is the distance between these two. Inside surface is 70. What's the distance between these two outside surfaces of the bracket? If you see from here, how much is the distance? Is there distance written? Yes, it's 70. You can see 70 written here. Okay, this inside is 70, this outside is 70. So there is actually no gap. So what we can do, we are going to select this surface and the surface over here. Okay, where is that surface? Which surface I select? Axis. Sorry, axis is selected somehow. I have selected this surface and this surface. Okay, no, not this one, the outside surface, this surface. Okay, now these two surfaces are selected and make it coincident and click OK. So we have made a concentric mate and a coincident mate, and you can see that when I bring it in the isometric, it's going to rotate. This thing is rotating, and it should rotate actually. Okay, this is actually the belt tightener is like this. It always rotates like this, and the belt actually passes over the pulley. Okay, and this bracket is actually made fixed on some part. Now I don't want that this should rotate, go all the way around. Of course, if you see this is going to stop somewhere over here. Okay, this cannot go all the way around. This is going to stop somewhere over here when it touches this position. When this flange touches this surface, it's going to stop, isn't it? So it cannot go beyond, it cannot go inside. This is actually the maximum limit. So what we are going to do, we are going to add a mate. We are again going to add a mate over here. First put the pins inside, then we will add the mate. Let's put the pin inside. First go to mate, click on this mate selection, click on this circular edge and this circular edge, which is over here, and make it concentric. Click OK, the pin is there. This is the concentric mate. The second is, you have to make a screw mate. So you have to make a screw mate between this thread and the thread over here. So go back to the advanced, and what is the threads per inch? It's 1.75, as you can see, 1.75 on this internal thread side and 1.75 on the external. Same, of course they have to be same. So click on the two axes. This is the first axis and this is actually the second axis. Click on the two axes. Okay, no, wait a minute, we have to go to advanced. Okay, and not advanced, mechanical, and we are going to click on 2, and this one right now distance per revolution is 1.75. Okay, we are going to select it afterwards. Click on this axis is selected, as you can see, and click on this one. Okay, this axis is selected and this is actually 1.75. Okay, click on reverse, because reverse is for right-handed threads. Okay, for right-handed threads you have to always check reverse. Okay, now click OK and you will see that the mate is actually there. Okay, you can see that the mate is there. Okay, okay, now I don't know why the whole assembly is rotating. Okay. Okay, let's fix it first of all. For the time being, let's fix it, okay? So that it doesn't rotate. Now what I'm going to do, let's make a mate, okay? What I will do, I will come to this is my frame. This white is my frame. So I will come here to the front plane of the frame. Okay, right? No, sorry, this is part 3. Part 3 is actually my bracket. I'm going to go click on the front plane of my bracket. This is the front plane. And then I'm going to come to the part 1. This is my part 1. And I'm going to come to the front plane of my frame. And what I will do, I will make them parallel. When you make the two plane, you choose the coincident as well. Okay, but parallel is a better option. You can make it parallel. And when you click on parallel, now you will see that it's not going to rotate because you have made the two planes parallel. Now, if you try to rotate the screw, now it's going to work. Okay, so now it's going to work. So how much is the pitch? The pitch is actually 1.75. Okay, because it's moving very slowly. It's moving very slowly, so you will have to do that. It's going to take some time. Okay, remember this is right-handed. It's moving how much? It's moving 1 revolution per. Okay, what we can do, we can suppress this one. Suppress this. Suppress this and move it inside, close. Is it suppressed? Yes, concentric. Okay, but even there is a screw mate in between. Let's suppress the screw mate as well. Because of the screw mate, it's not going inside. Suppress the screw mate. Now one thing is clear, you can move it close, so that you will have to do less work. Okay, sometimes the SolidWorks make trouble. Okay, make it close so that I will then have to do some less. Now unsuppress it. So unsuppress this concentric. Maybe you do not need this concentric when you are making the screw mate. Anyway, adding extra mate is not going to affect. And unsuppress this one. When you unsuppress, now you can see it's going inside easily. So there it is. So you can see now. Okay. Now let's save the document. File, save as, tightener, assembly. Okay, save it. So we have got this. Now I don't know what has happened. It has hanged actually. It's not working. Where is it? It's not working. I don't know what has happened. Okay, there it is. Okay. Now what I can do is that they look at this. This is going inside. Again, I have to apply a distance mate. You can apply a distance mate, or you can just fix it. So you can apply a distance mate if you want. My mouse is not working. I don't know what has happened to it. From mouse you can mouse wheel, you can zoom in or zoom out, but it's not working. I don't know what has happened. I will probably have to change it, because without mouse it becomes very difficult. Similarly, in the same way, you can apply the distance mate if you want. You can apply a distance mate between the two. So go to the mate and click on this advanced mate and click on this distance. Okay, and the minimum is going to be how much? The minimum is actually 0. Okay, between the two surfaces. So the minimum is going to be 0 millimeter, 0 millimeter mm, and the maximum is going to be how much? Let's come here, and you can choose any value anyways. I mean, This is 38, this is 5, and this is 20. So we know that it's going to come out. The thread length is actually 30. Thread length is 13. So you can choose like 13. 13 is okay. So choose 13, and that is okay. And select the two surfaces. So the surfaces, the first surface is this one, face 1, and the second surface is actually this one. I am unable to, you know, use my mouse wheel for some reason, and I have selected the two surfaces, and you can make it. You can make them. Now, if you rotate this direction, you can see that it's not going inside. But if you rotate in the other direction, okay, if I rotate in the other direction, now it opens till this point, and now after that it's not going up. It's not that this is not coming out because this 13 millimeter limit has been achieved. As you can see from here as well, this 13 millimeter limit has been achieved. That's why it's not coming up. Okay, so you can see that this 13 millimeter, this distance was 13 millimeter. So when you have achieved this 13 millimeter limit, it's not coming out. So now this one is done. So you are going to make this mate, screw mate. Okay, you are going to make this mate. This is done. Okay, this is not going. Okay, this mate is made. Now what is the last one? We need another mate. First of all, go to mate and select this axis and the axis over here and make it coincident and flip it. Actually flip the alignment. The alignment is not correct, so you are going to flip the alignment. Now the alignment is okay. Click OK. Now move this one close, otherwise it's going to make trouble. Okay, so move this one close. Now what we can do, what is the next mate? Advanced mate, no, mechanical mate, and that's the screw mate we have to select. And we have to select again the two axes. This is the first axis and this is the second axis. We make sure that the axes are there. Something else is not selected. You have to be very careful about this. And this is actually 1.75. And now what we'll do, click OK. The mate is actually there. So you can see that there is a mate. Okay. So the mate is there. Now again, the same thing which we are, now the mouse is working. Now it's working. So now what we have to do, the mate is there, you can see. Now we have to apply the distance mate. So what is the distance mate? We did this for the previous 0 and 13. This is 0 and this one is 13. Okay, 0 and 13, and the surfaces are actually this one and this one. So there is a 0 millimeter and a 30 millimeter. Click OK, and you can see that it's not going to go beyond 0. Okay, it's not going to go beyond 0. If I try to move it, it's not going beyond 0. You can click on this one and it's not going. Okay, so there it is. This is the assembly, and you can make the isometric view, and this is the assembly. Okay, you can add the materials. You can add the materials by looking at this table. So CI stands for cast iron. This is phosphorus bronze. Okay, so wherever the material is given, CI stands for cast iron, machine steel. Wherever the material is given, you can just add the material. And I'm going to, this is the assembly. Okay, and I'm going to, you can hide it. You can hide the axis now. Okay, now there are no more axes visible. You can see how it looks like in the front view. This is the front, this is the right, and this one is the top view. Okay, so now I am going to solve the other question. This was actually the assembly part. So the second part was make a 3D assembly file. So we did this part number 2. Now the part number 3 will be done in a separate video. Part 3, 4, 5, 6 will be done in a separate video. Okay, thank you.